Welcome back to the deep dive. So you guys have sent us something really, really interesting to look into this week.
Yeah, this is fascinating.
It's OpenAI's native image generation system card from March 25th, 2025.
Yeah.
And it's all about this new 4o image generation.
It is. And a really interesting document to dive into in terms of just looking at what these capabilities are, how they're thinking about safety. It's some really big advancements, obviously, which come with new considerations.
Yeah, so for image generation, it sounds like it's a big leap forward even from, what we've seen with DLAA. This card, it talks about being able to create photorealistic images, taking an image that you give it and transforming it. It can follow these very detailed instructions, like putting text into images cleanly.
Right.
And the fact that it's native, it's integrated right into GPT-4o suggests that, we're talking about some really nuanced image creation here.
Absolutely. It's that native integration within GPT-4o, which I think is one of the big game changers.
Yep.
In terms of being able to leverage sort of all of the understanding and reasoning that the broader model has. So when they say subtle and expressive, I think they're referring to the fact that, it should hopefully be able to interpret all of the nuances in your prompts.
Yeah.
And, give you something that's even more aligned with what you had in mind.
Yeah. So really this deep dive is to try to understand, the core safety challenges, evaluations, and the mitigations that they're using in this new tech.
Exactly.
To try and to really give you a sense of how they're thinking about the risks that come with these new capabilities.
Yeah, absolutely.
So, right out of the gate, the first section that really jumped out to me was new risks from native image generation.
Right.
And they talk about how, they're moving away from, this diffusion model that was used in DLE, to this autoregressive, natively embedded approach within ChatGPT.
Right.
So that seems like a pretty big shift.
Yeah, it is. It is a big shift. And I think, the autoregressive nature of this and, the way it sort of builds images piece by piece in this way that's, natively integrated within ChatGPT really, I think, changes the landscape of risks that you have to be thinking about.
Yeah.
And, in particular, they highlight 3 new capabilities that are sort of worth noting from a safety perspective.
Yeah, which are image-to-image transformation, the photorealism, and then the instruction following, right?
That's right.
So let's start with that image-to-image transformation. So this is the ability to upload an image and then, have the model create a related or modified image. So what kind of risks are introduced with this ability?
Well, I think, what's interesting about this is the potential for, detrimental or harmful alterations. You can imagine a case where someone uploads a photo of an individual and then, they generate a modified version that could be used to, spread misinformation or harm their reputation or worse.
Right.
And so I think, the ease with which you can sort of take any visual now and sort of transform it introduces sort of a whole new set of challenges.
Yeah, and then there's that, that photorealism. I mean, we've seen AI-generated images get pretty realistic in the past, but, it sounds like, they're really taking it to the next level here where, the output could be, pretty much indistinguishable from a photograph. So why is that, why does that increase the safety concerns?
Well, I think if you take a step back, the more convincingly real an image appears, the more difficult it becomes to tell it apart from, authentic content.
Right.
And so this increased realism, directly correlates with, an increased potential for misuse.
Yeah.
Especially in areas like, the spread of false information, impersonation, and, the creation of non-consensual intimate imagery, right? If an AI can generate an image that looks exactly like a photograph, it just becomes a much more powerful tool for people who have, malicious intent.
Sure. It blurs the lines with reality in a pretty in a way that could have some pretty serious consequences. And then the third new capability is that detailed instruction following,
right?
Including being able to reliably render text and diagrams. So this sounds really useful in a lot of ways.
Yeah.
You could create helpful visuals and stuff, but but they point out the risk here too, right?
Yeah.
So what are the worries?
Well, I think this sort of brings up this important point about the potential for dual use. On the one hand, the ability to generate a helpful schematic or educational diagram is that's a huge advancement.
Right.
But that same capability can also be used to generate, harmful content.
Right.
Like, detailed instructions for creating weapons or other dangerous items.
Yeah.
The precision with which, 4o can follow, intricate instructions, including, putting text into these diagrams, means that it could, potentially generate some very, very specific and potentially problematic visual guides.
Sure.
And I think it's that, combination of these three advancements, right? Image transformation, the photorealism, and the instruction following is what creates, this new area of risk that, previous models weren't quite capable of in the same way.
Right. So, okay, so with all of these, new potential problems, it is comforting to see that they have, what they call this safety stack, which sounds like, a multi-layered approach to try and, to prevent this harmful content from being generated.
Exactly.
So can you walk us through sort of these, the different levels of the stack?
Yeah, absolutely. So they basically describe 4 key components to the safety mitigation.
Okay.
The first line of defense is what they call chat model refusals.
Okay.
And this happens right within ChatGPT itself. So, the core language model, based on its training about what is, allowed and not allowed, can, analyze your prompt, right? The text prompts that you give it, and just decide not to even engage the image generation tool if it detects, a policy violation in your text request.
Okay, so even before it gets to the point of generating an image,
Yep.
it's checking the text input.
Exactly.
So what happens if a prompt, seems fine on the surface, but could still lead to, a problematic image?
Right. So that's where the second layer comes in, which is called prompt blocking.
Okay.
So after ChatGPT has sort of decided, okay, I'm going to call the 4o image generation tool. But before the image is actually created, there's a set of text and image classifiers that step in.
Gotcha.
And those classifiers, specifically examine the prompt, including both the text that you've written and any images that you've uploaded.
Mm-hmm.
And if they identify it as, violating OpenAI's, usage guidelines, they will block the image from being generated. So this is really a proactive measure, right?
Yeah.
To try to stop, disallowed content before it even exists.
Gotcha. So that prompt blocking is trying to catch it before the image is even made. So what if something does slip through,
Right.
That initial screening and an inappropriate image actually gets generated.
Right. So that's where the third layer comes in, which is called output blocking.
Okay.
So after the image has been generated by 4o, there's actually another set of checks that are performed on the output image. And that includes things like, specialized classifiers for detecting CSAM, a safety-focused multimodal reasoning monitor, which is basically an AI model that's specifically trained to, understand and apply OpenAI's content policies, but in a visual context. So if that generated image is, found to violate their usage policies, it blocks from being shown to you.
Gotcha.
So this is sort of a final safety net
Right.
after the image has already been created.
Right. And then that fourth component was that increased safeguards for minors.
Right.
So how does that work?
So basically all of these measures that we've just talked about, are applied even more stringently when they believe the user is under 18. So, that means stricter thresholds, more aggressive blocking of content that might be inappropriate for younger users.
Yeah.
And furthermore, anyone under the age of 13 is just completely prohibited from using any of their products or services. It's, it's recognizing that there's, particularly important responsibility when it comes to, protecting children.
Right. Right. So it sounds like a pretty comprehensive, system. And then they go into quite a bit of detail on how they actually, tested the effectiveness of this whole safety stack. And they use 3 main approaches for evaluation.
Yeah.
Right. External red teaming, automated red teaming, and then offline testing using real world scenarios.
Right.
So let's start with that external manual red teaming. What exactly did that involve?
Yeah. So what's interesting here is that they basically worked with, external red teamers, right? They partnered with red teamers in their red teaming network, and also with Scale AI.
Okay.
And so these are folks that, are sort of experts in finding, vulnerabilities and trying to, bypass safety measures in AI systems.
Mm-hmm.
And so they were given, specific areas of concern to focus on, and they were actively encouraged to try and find ways to, to make the model generate harmful content,
Right.
right? To essentially try to break it.
Right. So they were deliberately trying to get the model to, to create inappropriate content.
Exactly.
So what happens after that, after that manual red teaming process?
Yeah. So they took, thousands of these interactions where, the red teamers had tried to bypass the safeguards, and they turned them into automated evaluations.
Gotcha.
So they basically took these, the results of these manual tests and created, sort of a systematic way to test their safety stack against, a large and diverse set of, challenging prompts. And in these tests, they track two key metrics. The first is what they call not unsafe. It's basically measuring how often the system does not produce, policy violating output.
Okay.
And the second metric is what they call not efficies, which was basically measuring how often the system does not refuse, a request that is actually compliant. So it's measuring, how often it doesn't block something that is actually, within the guidelines.
Right. So what are the results, from this external red teaming data?
Yeah. So table 1 of the document gives us those specific numbers. And what they find is that, with just the system mitigations in place, meaning, prompt blocking, output blocking, but no chat model refusals.
Okay.
The not unsafe rate was, 0.955, and the not unsafe use rate was 0.941. When they add the chat model refusals as that first line of defense, the not unsafe rate actually improves to 0.971. But, interestingly, the not over refuse rate does drop a little bit to, 0.856.
Yeah.
Which suggests that, while the chat model is helping to, catch more of those unsafe requests, it also might be leading to the system, incorrectly refusing some harmless requests.
Right. Yeah.
More often.
It's that constant balancing act.
Exactly.
Okay. So then they talk about, automated red teaming.
Right.
So how is that, different from the manual approach where they used human testers?
Yeah. So in automated red teaming, instead of, relying on humans to sort of come up with these challenging prompts, what they do is they use their own internal understanding of their policies to actually automatically generate synthetic conversations.
Okay.
And these conversations are specifically designed to, to test how well the system adheres to each, specific aspect of their content guidelines. And this allows for much more, comprehensive and systematic testing, right, of their policy implementation across, a wide range of potential violations. And they generated thousands of these synthetic conversations, both with and without, including image uploads in those prompts.
And what was the performance, with that automated testing?
Yeah. So table 2 shows, those results, and, similar to what they saw in the, the human red teaming, when they just used the system mitigations, the not unsafe score was 0.969, and the not of refuse score was 0.899. When they add the chat model refusals, the not unsafe score increases slightly to 0.975, and the not a refuse score drops to 0.830. And so I think what's interesting here is again how similar these performance numbers are to the human red teaming results, which gives them, more confidence that their policies are, are being applied consistently across these different types of inputs.
Right.
Yeah.
That consistency seems really important. Okay, and then the third evaluation method was that offline testing using real world scenarios.
Right.
So what did that involve?
So basically this involved testing the safety stack on text comps that were designed to reflect, actual situations that people might actually, type into the system. And so they used examples from across, their different safety categories to sort of make sure the evaluation was representative of how the model would be used, in practice.
Sure.
And so this helps them understand how well those safety measures actually perform under realistic conditions.
Right.
And identify any areas that, might need further, refinement.
So and the results from that real world scenario testing.
Yeah. So table 3 gives us those numbers, and what they find is that, with just the system mitigations in place, the not unsafe score was 0.929, and the not ever refuse score was very high, 0.996.
Okay.
When they use both the system mitigations and the chat model refusals, the not unsafe score increases slightly to 0.932, while the not ever refuse score stays, very high, at 0.993. And so it seems that, in these more realistic scenarios, the system is very good at not incorrectly refusing, legitimate requests, although the not in safe score is a little bit lower than in the red teaming exercises,
Yeah.
which might suggest that, real world prompts can be just a bit more nuanced
Right, right.
or unexpected.
Okay. Yeah, makes sense. So then they go into, sort of a discussion of specific areas where safety, is a major concern. And, child safety is obviously, a key focus. So what are the specific measures that they're highlighting, in that area?
Yeah, so they start out, by emphasizing, their really strong commitment to preventing, detecting, and reporting CSAM, across all of their products, including this, this new 4 image generation, and they're putting in, a number of efforts to address this, including things like red teaming, that's specifically focused on child safety, following recommendations from organizations like Thorn, and robust scanning for CSAM in both the images that you upload and the images that that the system generates.
Right. And they mentioned some specific, model policies too, right?
That's right. Yeah.
Oh.
So for example, they're not allowing users to edit uploaded images that depict photorealistic children at launch.
Okay.
And they're going to be evaluating, whether that can be done, safely in the future.
Right.
But for now, that's not allowed. They've also reinforced their existing safeguards against CSAM, for both editing and generating images.
Okay. And so, what about the actual mechanisms, for detection? Yeah. What are they doing to actually detect this, this potentially harmful content?
Right. So they're using, sort of a multifaceted approach here. First of all, for any image that is uploaded, they've integrated with, Safer by Thorn to detect, known CSAM.
Okay.
And so if a match is found, the content is immediately rejected. It's reported to NCMEC, and the user's account is banned.
Right.
They also utilize, Thorn's CSAM classifier to identify, potentially new CSAM.
Okay.
Right. That's in both, again, uploaded images and images that are generated by the model.
Uh-huh.
And then in addition to that, they have a multimodal moderation classifier that is specifically designed to detect and block any generated sexual content that involves minors.
So it sounds like they're really taking this, seriously.
Yeah.
Which they should.
Yeah, absolutely.
And then they mentioned this thing called a photorealistic person classifier. So what is that, and how does that contribute to this whole child safety thing?
Yeah, so this is basically a classifier that's built based on their existing under-18 classifier for Sora.
Okay.
And it analyzes any image that is uploaded,
Yeah.
and makes a prediction as to whether it depicts no photorealistic person, a photorealistic adult, or a photorealistic child.
Okay.
And interestingly, if an image contains both an adult and a child, the classifier is designed to predict photorealistic child.
Okay.
And so at launch, photorealistic generation of children is only allowed if it's not an edit of a photorealistic minor, and if it complies with all of their other safety policies.
Okay. And they give some data on on how well that classifier actually works.
They do, yeah.
So what did they find?
Yeah. So Table 4 gives us those details, and they find that for identifying any photorealistic person, whether it's adult or child, the precision was 0.905. And the recall was 0.99.
Okay.
For specifically identifying a photorealistic adult, the precision was 0.80 and the recall was 0.776.
Cool.
And then for identifying a photorealistic child, the precision was also 0.80 and the recall was 0.97.
Okay.
And they point out that they've basically tuned this classifier to be very cautious, meaning that it will err on the side of classifying ambiguous cases as child,
right?
For safety reasons.
Yeah.
Even if that means, occasionally misclassifying, a younger looking adult.
Right. Right. Makes sense. Okay. So moving on to another area that, that often generates a lot of conversation is that, the whole artist styles thing.
Right.
There's been a lot of, talk about, AI models potentially mimicking the work of existing artists. So what's their approach to this, with 4o image generation?
Yeah. So they acknowledge, the concerns that have been raised in the creative community. And they are, at launch at least, taking a very cautious approach.
Okay.
So they've implemented a system that will refuse to generate an image specifically in the style of a living artist.
Okay.
And they say this is sort of a temporary measure as they learn more about how 4o is being used by the creative community and just better understand the implications. But for now, that's how they're addressing that concern.
Yeah. That seems like a prudent step, at least for now.
Yeah.
So what about the ability to generate, depictions of public figures? I mean, that's another area that can be, tricky and, potentially misused, right?
Yeah, absolutely. So 4 image generation is capable of creating depictions of public figures based on text prompts. And at launch, they're not blocking the generation of adult public figures.
Okay.
But they are applying, the same safety measures that they use when you upload a photorealistic image of a person and try to edit it.
Okay.
And so that means that they aim to prevent the generation of photorealistic images of public figures who are minors, as well as any content that violates their policies on things like violence, hate speech, illegal activities, and sexually explicit material.
And they mentioned that public figures can opt out, of having their likeness generated. Right?
That's right. Yeah. So public figures can specifically request that their depictions be blocked by the system. And they highlight this as a more fine-grained approach.
Yeah.
Compared to what they did with DLE, where they basically used more technical limitations to prevent any images of public figures from being generated at all.
Right.
And so they say that this new approach potentially allows for more educational, historical, satirical, and political speech.
All right.
But they also emphasize that they will be closely monitoring how this is used.
Right.
And they're going to adjust their policies if necessary.
Right. Right. Yeah. So it sounds like they're trying to find that balance between, that creative freedom, but also preventing, potential harm or misuse.
Exactly.
And then they talk about, the whole topic of bias, which is, a very important topic.
Absolutely.
So how does 4o image generation compare to their, their previous models like DOE3 when it comes to, this representational bias in the images that it creates?
Yeah. So they basically say that 4 image generation shows, some improvement over DLE3 in certain aspects of representational bias, but they acknowledge that challenges still exist,
right?
Particularly in terms of demographic representation,
right?
And so they plan to continue refining their approach and developing post-training techniques to mitigate bias, including using a more diverse set of examples in their training data.
Okay, and they give some specific findings from their analysis of statistical bias.
Yeah.
Using these underspecified prompts. So what did they look at in this evaluation?
Yeah, so they basically evaluated the model's outputs for simple prompts like a happy person, a doctor, or 3 construction workers, without specifying things like gender or race. And they looked at the overall distribution of generated characteristics.
Okay.
But they emphasized that the frequency of what they call heterogeneous outputs, meaning how often the model generated more than one type of person across multiple attempts, and the skew, which they measure using Shannon entropy, those are really more informative for understanding bias.
Yeah.
And higher heterogeneity and higher entropy suggest less bias.
Okay.
In the output.
So what about specifically gender bias, right? In the images generated by 4?
Yeah. So while they did observe some progress compared to ALE3, the outputs from 4 image generation still tended to feature male subjects more often.
Okay. Right.
And so they are specifically focusing on increasing the frequency of these varied outputs and improving the Shannon entropy as key indicators of progress towards more balanced gender representation.
Mm-hmm.
And tables 5 and 6 in the document show the distribution of genders.
Okay.
And those entropy and heterogeneity metrics.
Okay. So what about racial bias? How did 4o perform in terms of representing, different races?
Yeah. So they found that, while both models still tend to, generate images of white individuals more frequently,
Mm-hmm.
for image generation did produce a noticeably broader variety of individuals from different racial backgrounds in response to the same prompts
Okay.
compared to DLE3.
Gotcha.
And again, table 7 and 8 in the document, break down sort of the racial distributions
Okay.
and show that, improved, Shannon entropy and heterogeneous output frequency.
And what about bias related to, skin tone?
Right.
That's another, important aspect of visual representation.
Absolutely. So in terms of skin tone, they found that both models did show a tendency to, produce lighter skinned individuals more often.
Mm-hmm.
But but they also found that the majority of prompts still resulted in, a set of generated images that included a range of diverse skin tones.
Gotcha.
And so, tables 9 and 10 in the document show, the class distributions, the entropy, and the heterogeneous,
Yeah.
figures,
Yeah.
and indicate that, while lighter skin tones are still somewhat overrepresented,
Uh-huh.
there's a degree of diversity
Okay.
present in the generated sets.
Gotcha. Gotcha. And then they talked about this thing called what they call ahistorical and unrealistic bias.
Yeah.
So what does that refer to, in this context?
Yeah, so this particular evaluation looked at whether the model would introduce characteristics that are you.